Welcome to STEM in the House. I'm your guest, Dr. Adams. Today we are going to continue our work with structures as civil engineers, and we are going to look at our paper table challenge. The materials that you will need for this challenge are newspaper, masking, or you can use painter's tape. You need a pair of scissors, possibly for cutting. Remember, you need an adult if the scissors are sharp. A ruler, because the challenge requires that the table be 8 inches from your flat surface. And you will need some books to be used as our tester for how strong our structure is. So let's begin by talking about what we discussed in our last challenge about what are the strongest shapes that you can use in order to build a reliable or sturdy structure. We talked about rectangles or squares, and we also talked about triangles. These are two shapes that I've prepared in advance from newspaper and using masking tape to put them into shape. So here is our square shape. Rectangular. Let's put some pressure on it, engineers. Notice how the top crumples when I put pressure on a rectangular shape. Let's try it with our triangular shape. We put some pressure on. It doesn't buckle as much if we exert it right on the top of the structure. So which one do you think will be the strongest for your paper table challenge? A rectangle or a triangle? So, we take our newspaper and we need to roll our newspaper on what we call a diagonal. So here's my piece of newspaper, large regular newspaper you get at the store, and I begin at the very corner and I roll. So let me stop for a minute, engineers. I rolled a couple of samples for you. Here's one. Notice how large it is. It's loose. Not as sturdy. Here's one that's medium size, a little bit more sturdy. And here's one that is rolled extremely tight, and it is a stronger support. So we want our newspaper to be rolled as tightly as possible, starting in the corner and rolling until we get to the end. And as we're rolling, remember, engineers, we want this to be a tightly rolled piece of newspaper. Similar to this, this is what not to do. So we continue to roll. Continue to roll. Don't forget to have your tape out. And we're rolling on a diagonal. And oops, my tape got stuck to my paper, engineers. And we continue to roll, continue to roll, continue to roll, continue to roll, and continue. And now we tape it. So I'm going to wrap the tape around, wrap the tape around, wrap it until we secure our tube shape. Wrap our tube shape. So next, remember the part, scientists, where the problem here is the challenge is to build a sturdy table-like structure at least 8 inches from our flat surface, and it should support as many of our weights, in this case we are going to use books, as possible. Additionally, we need a flat piece of cardboard. Well, I found a box in my home and I cut it, and so we need this for the top of our table. So engineers, in advance, I prepared my triangles. So you have to imagine, what should your table look like? Well, I imagine in my head, and this is where you would have your paper and pencil to sketch, I imagine a table made of all triangles, because I said strongest structure, triangles. So here is my structure. Not exactly flat and straight, but here we go. So I've got 3 triangles here we join. Remember our other challenge where we made our straight across bridge. Triangles straight across this way, 3. Triangles this way. And then for additional support, I put a combination of 3 triangles in the center. So now I'm ready to put my top or cardboard on the top for my table, and now I'm ready to test. Remember, 8 inches from the table. And this may be a little difficult. You may have to take it apart, but remember, masking tape removes easily. So let's test it. 1 book, and I'm going to reach over and get another book, a 3rd book, a 4th book, a 5th book, 6, 7, 8, 9. You get the point, engineers and parents. You continue to stack and see who can hold the most books on their paper table. The paper table challenge can be a competition with you and your family, and it uses products that you can easily get or are readily available in your home. Until we meet again, this is STEM in Your House with Dr. Adams.